So today's lecture is on multivariable linear systems. Thank you, Kellen. So this is chapter 7, section 3. We will be learning how to solve multivariable linear systems. Sounds a lot more complicated than it actually is. And this will kind of prepare us for matrices in chapter 8, which will start next class.
Did you start recording?
I did. So it's most instructive to first go through an example. Let's say we're asked to solve for x, y, and z. We're given x minus 2y plus 3z equals 9. Negative x plus 3y equals negative 4. And 2x minus 5y plus 5z equals 17. Okay, and let's say we're trying to solve for x, y, and z. You'll notice that I've done a careful job of actually aligning all the x's and all the y's and all the z's. So that's intentional, so make sure you're doing that too. And you'll see why once we get to matrices. Okay, so the idea behind solving these equations is that we try to manipulate them, like multiplying them by something or adding them together or subtracting them from one another. We try to do those manipulations in order to isolate the variables that we desire. Okay? So for example, my first step would probably be to add the first two equations together. And when I add those together, I can eliminate the negative x in the second equation. Okay? So I'll do that. I'm going to leave the first equation alone. And then I will add the first equation and the second equation. So we'll add these together, and that's going to give me y plus 3z equals 5. And the third equation I'll leave alone for now. All right. So you guys see I just added the first two equations. So x minus x is 0, minus 2y plus 3y is positive y, and 3z plus 0 is 3z. And then 9 minus 4 is 5. So that's how I got y plus 3z equals 5. Okay? All right, so next step, I'm going to try and get rid of this 2x here on the bottom. And in order to do that, I'm going to multiply the top equation by negative 2. Okay? And if I multiply the top by negative 2, then I can add that to the third equation, and that will eliminate the 2x on the bottom. So I will do that. Let me use some colors. Okay, so that's going to give me, minus 2, right? Minus 2x plus 4y minus 6z equals negative 18. I'm going to keep the second equation the same. And then the final equation I'll also leave alone for now. Okay. And then now I can add the first and the third equation to get rid of the 2x here. So I will do that. I'll add these two together. I'm also going to revert the first equation back to what it was before because I don't need it to be multiplied by negative 2 anymore. So I'm going to write it to what it was before, which is x minus 2y plus 3z equals 9. Second equation I'm going to keep the same for now. Then finally, the third equation is going to be the addition of the first and the third now. So minus 2x plus 2x, that cancels out. 4y minus 5y, that's negative y. So I have negative y minus z, because that's negative 6 plus 5 is minus z. And so that's all equal to negative 1. Okay, any questions up to here? Yeah, Daniel?
Would you like to explain the whole thing again?
Okay.
Like, show another example.
Another example?
Yeah. I'm sorry.
This is algebra 1, yes. Okay. Systems equations, I'm not too sure what's unclear. Anybody want to ask a more specific question? So, the idea, we're just adding equations together in order to get rid of variables, right? So, for instance, in order to eliminate the x from the second equation, we add the first two equations together, which gives us this new second equation, right? Does that make sense? So x plus negative x, that cancels out. Negative 2y plus 3y, that gives us this positive y here. And the 3z plus the empty space there, which is 0, is just 3z. And then finally, the constant on the right side is 9 minus 4, which is 5. So by manipulating the first and second equations, by adding them, I can replace the second equation with this equation, which no longer has an x in it. So the whole process is that I'm trying to gradually reduce these equations until more and more variables disappear, and I'm only left with x, y, and z by themselves.
Okay, and then what's the next step?
Yeah.
Okay? The next step, I multiplied by negative 2. I multiplied the top equation by negative 2. And the reason why I want to do that is because I want to get rid of this 2x down here. And so if I multiply the top by negative 2, and I add the first to the third equation, then that will eliminate this 2x here. So I multiplied this top thing by negative 2, which gives me negative 2x plus 4y minus 6z equals negative 18. All right? And I just added that thing to my third equation, which gives me negative y minus z equals negative 1. All right? If I added the first and the third equations, then the 2x will cancel out. The 4y and the minus 5y gives me negative y. And the negative 6z and the 5z gives me negative z. And the negative 18 and the 17 give me negative 1. So that's how I got negative y minus z equals negative 1.
So
Yeah.
the third line would be the answer?
No,
Or would it be-
we're not done yet.
We're gonna combine that, right?
We're gonna keep eliminating the variables. Okay, any questions though? Up to here? Okay. Well, my next step is fairly obvious. I'm going to add the second and third equations together. And that will eliminate this negative y here, right? So my next step, I'm going to keep the top equation the same. Okay, it seems tedious to keep writing this over and over again, but you have to in order to see the connection to matrices later. Okay, so I'm going to add these two together. So y minus y is 0. 3z minus z is 2z, so that's what I'm left with here. 2z equals 5 minus 1, which is 4. Okay, and then my final step, I'm going to divide this thing by 2. So my final set of equations is x minus 2y plus 3z equals 9, y plus 3z equals 5, and z equals 2. And so this is what we call row echelon form. Very important term. This is called row echelon form. And once we've written a system of equations in row...
Can you scroll down? Can you scroll up just a little?
Yes. Once we've written our system of equations in row echelon form, actually solving for x, y, and z becomes very simple. And so that's why we like it. And I'll show you why it's simple right now. Okay? But any questions up to here?
Yeah.
We could just take a
Kellen?
So the top equation always is going to be the same at the final answer as it was originally?
Not necessarily. There's some cases where it's not. But here, okay, let me first explain what exactly row echelon form is. Okay, so row echelon form is always this kind of staircase pattern of equations, okay, where the first equation starts with an x, the second one starts with a y, and then the third equation starts with a z. So you'll see one of the hallmarks of row echelon form is that there's empty space under the y and empty space under the x. Mix those up. And the second important feature is that the coefficient of x and the coefficient of y and the coefficient of z is all 1, okay? So that's the requirement for row echelon form. So to answer your question, Cullen, if we had started with something like, 3x minus 2y plus 3z, then to get it into row echelon form, we would have had to divide by 3 to get the coefficient of x to be 1. Okay?
So you need the first variable and the final answer to be 1.
Yep, we need these coefficients to all be 1. This one, and this one. And once those are all 1, and we have this staircase format, that means we're in a row echelon form.
Why did you multiply by -2 in the second step?
I multiplied by -2 so that I could cancel out with the 2x here.
Okay.
Yes. So what I could have also done was multiply by 2 and then subtract the first equation from the third equation. The reason why I multiply by a negative number instead of a positive number is because it's easier to add than it is to subtract. And you'll make a lot less mistakes when you do that. So that's my personal recommendation, multiplying by a negative number. Okay, let's say we now have it in row echelon form. How do we then solve for x, y, and z? We use a process called back substitution. Very simple. Just a word. Back substitution. That means we start with z, and then we try to solve for y, and then we use y and z to try to solve for x. Very easy. You can look. Okay, so if z equals 2, that's the thing we found, right? If z equals 2, then we're able to just back substitute.
The 1 plus 6 would be 5.
That's correct.
Meaning y is -1.
That's correct.
And
So x minus 2y plus 3 times z, and z is 2. So that means we're able to write this. And then the second equation becomes y plus 3 times 2, or 6, equals 5. And then z, obviously that's just 2, so just write 2 equals 2. And so this means that y equals 5 minus 6, which is -1. But then this means that x minus 2 times y, which is -1, right? We just plug in the values of y and z that we found already. Y minus 2 times -1 plus 3 times 2 is equal to 9. And so that means that, this is getting very tight, that means that x equals 1.
1.
And z equals 2. Okay, so my final solution is x comma y comma z equals 1 comma -2 comma, 1 comma -1 comma 2. Okay, so you see, once we get it into row echelon form, solving for x, y, and z is almost trivial. It's very easy. Okay, questions? That's the general procedure. And there's a word for this. It's called Gaussian elimination.
Would that be similar to the formula?
Formula?
Yeah.
What formula? That's different. Yeah.
So this guy just discovered a bunch of things.
Yeah, Carl Friedrich Gauss. Questions? Let's do another example, shall we? Okay. So, general procedure. 1. Use row operations. So that just means manipulating equations to simplify into row echelon form. So that's the first step. And what are some valid row operations? Well, we're allowed to first interchange different equations with each other. So we're allowed to flip equations. So 1 could become 2, and equation 2 could become equation 1. Interchange equations. We're also allowed to multiply equations by a constant, like -2, like we did above.
Wait, can you slow down a little bit?
Multiply equations. I'll try. And we're also allowed to add equations together. Or subtract. Okay, so those are valid row operations. And we try to use those in clever ways in order to reduce our system of equations into row echelon form. And then once we have it in row echelon form, we use back substitution.
This is a new concept, Mr. Mike. Could you go like 3 quarters of the speed going in now?
I don't know how new it is, but I will try to go slower. I do think this was algebra 1, wasn't it?
I think we just deal with 2 lines and 2 variables.
You guys didn't have 3 equations in
No.
algebra 1?
I mean, if we did, it was just 2 variables.
I went from Common Core math to geometry. So.
Common Core. I managed to escape that, thankfully. Okay, let me do another example. Let's say we have yeah.
How come, like, when you subtract something from something, only one of them changes? Like, one of them stays the same and the other one is...
That's correct. We want to keep one. Yeah.
How do we know which one's...
You could keep any of them. We just keep the one that's more convenient for us. So for example, when we added these two together, I want to keep the top one because I know that for row echelon form, I need this x here, right? So I kept that there. And then the one that I wanted to cancel was this square, right? Because in order to get row echelon form, this square has to be empty. So I wanted to cancel that one out. Okay. It's kind of like a game, right? You start with something that looks like this. And you try to do some clever steps in order to eliminate these squares. Right? To get it into row echelon form. Right? It's like, I don't know what game this is like. Tetris? No. Connect 4? Okay, let's do this example. Okay, so in order to get row echelon form, quiet please guys. In order to get row echelon form, I need this thing in the top left to be x without any coefficient, right? With the coefficient of 1, because that's what's required for row echelon form. So what you could do is divide the top by 3, but an easier way is actually just to interchange these two equations, because we can just move this to the top instead. So we'll do that. We'll interchange 1 and 2. That gives us x minus y equals 0 on the top, and we're just going to switch them. Okay, so that gets me this desired x on the top left for row echelon form. Okay, and then I'm going to multiply the top by -3. The reason being, I want to eliminate this thing on the bottom left, and so I'm going to multiply the top by -3. So that's going to give me -3x plus 3y equals 0. And then I'll keep the bottom to be the same.
Wait, do you have to do it in echelon form? Or is it just helpful?
We do have to do it in row echelon form in this section, because
Did I do it right?
I'll check later. Okay, so now we're going to add the first one to the second one. That's going to give me -3x plus 3y on the top. And on the bottom, the 3x is going to cancel out, and I'm going to be left with just y equals -1. Got it? And then to get it into row echelon form, I also have to divide the top by -3 and change it back to what it originally was, right? So I'm going to write as my final step, x minus y equals 0, and y equals -1. And that is row echelon form, because I have this staircase pattern with coefficients of 1. Okay, and then if you do back substitution, you'll find that x comma y equals -1, comma -1. Right? Because x equals y and y equals -1. Questions? Is that slow enough? I don't know.
Yeah, it's good. It's a good pace.
Okay, let us do another one. Back to 3 equations, unfortunately. You should be thankful that there's no homework problem with 4 equations.
No, what? How bad can it go?
More work.
Like infinite?
Well,
It's gonna give us like a 6.
what's the most equations you've done in 11 months?
10,
Um,
27.
6.
Not many. I mean, when it gets above 5, you just use a computer, right? Okay, let's do another one.
Just something that became famous due to graphical ones.
Okay, let's try this one. When you guys go to actually do STEM majors and do math in like college in real life, you don't do algebra anymore. You just use a computer for everything.
Say again?
In real life, you use a computer for all this stuff, all the algebra stuff.
Then why are we still learning about this?
Because you won't understand how the computer does it if you don't know how to do it. My computer died. Yes?
Can you cancel out y and z with 1 and 2 equations?
You could, but you wouldn't be getting it into row echelon form. And that's still what we want to be doing right now, at least.
So I can get it.
In theory, you could. But for the procedure that we need to learn today, we have to start with the top and work to the bottom. Okay, let's start. So, first step, I want to cancel out this thing here. And so what am I going to do? I'm going to multiply the top by -2. I want to cancel out this 2x here, so I'm going to multiply this top thing by -2. All right, that's going to give me this. -2x minus 2y minus 2z equals -12. 2x minus y plus z equals 3, and 3x plus y minus z equals 2. So I kept the bottom two the same. Okay, now I'm going to cancel out that 2x by adding the first 2 equations. I'm going to add those together. That's going to give me this. Okay. So I'm going to revert the top one back to what it was originally. Because I just temporarily multiplied it by -2. So I'm going to change the top back to x plus y plus z equals 6. And then I'm going to add these two together, right? That's how I cancel the 2x here. That's how I cancel out that 2x. So that gives me...
-3y minus z.
very good. Yeah, let me use red. -3y minus z equals -9, right? Because these two x's cancel out. And minus 2y minus y is -3y. Guys, quiet please. Maybe the reason why it's so confusing is because you talk so much.
Dang.
Minus 2z plus z is -z. And -12 plus 3 is -3.
On the survey,
I don't particularly care. Okay, you guys see how I got this? I added those first 2 equations together, which cancels out the 2x here. Right? I mean, the idea behind reducing it to row echelon form, I want to cancel out all these 3, right? That's the goal. All right, next step. Next step is to get rid of this 3x here. And how am I going to do that? Well, I'm just going to multiply the top by -3. Easy. Okay, you see that if I multiply the top by -3, then that's going to get rid of this 3x here, if I add them together. -3x minus 3y minus 3z is equal to -18. I'm going to keep the second equation the same. Third equation, going to keep that the same. Okay. Then my next step is to add the first and the third equation together. Adding the first and the third. And the reason why I want to do that is because I want to get rid of these x's. I want to get rid of this x specifically, right? So what is that going to give me? Is this too fast?
2y minus 4z equals 6.
Not too fast? Okay, I'll keep going. I'm going to revert the first equation back to the original. Okay, and this 3x is going to cancel when I add it to the first equation. And -3y plus y becomes -2y. And -3z minus z is -4z. And -18 plus 2 is -16. So that's what I'm left with. Okay. Next, questions up to here? Next, my goal is to get rid of this -2y. That's my last step, right? So what am I going to do? It's a little tricky. I'm going to multiply the second equation by 2 and the third equation by -3. Okay, and once you do that, these are going to cancel. Why is that? That's because this is going to become 6y, and this is going to become, first one's going to become -6y, and this is going to become 6y. So they'll cancel nicely. So we'll do that. First one stays the same. Second one, after I multiply by 2, becomes -6y minus 2z equals -18. And then the third equation is going to become 6y plus 12z equals 48, right? Because -2 times -3 is 6, -4 times -3 is +12, and -16 times -3 is +48.
How long should solving these equations take you?
You should be writing out every step, so it will take a while. Yeah. The more steps you write, the less mistakes you'll make. I can promise that. Because this is all arithmetic, right? And we're not that good at that. Okay. Next, I will be adding. Okay, so another thing you could have done was multiply these by fractions, like multiply that by -3/2, or multiply this by -2/3. The reason why I didn't do that is because fractions are hard, right? And I don't want to create additional difficulties for us. Okay, adding these final two equations together. That's going to leave me with this. So the first and second equations I'm going to keep the same. And then if I add these two together, those cancel out. And -2z plus 12z becomes 10z. And -18 plus 48 is 30. Okay, so I have, that's correct. And I have the correct format for a row echelon form, but I don't have the right coefficients yet. So what I need to do is divide this by -6 and divide this by 10 in order to get those coefficients that I want, right? And so that's going to leave me with this. If I divide the second one by -6, I'm left with y plus 1/3 z. Here the fractions are unavoidable, right? Y plus 1/3 z equals +3, and z equals 3. 30 divided by 10. Okay? And that is our desired row echelon form. And now solving is pretty easy. questions.
When's your next test or quiz?
November
November?
10th or something.
November 10th.
That's the test. We have 2 quizzes this unit.
Wait, that's when the test is?
I'm happy to add more. The next quiz is next Wednesday or something. Okay, any questions about this process? It's really pretty simple, just takes a while. It's
Variables are 1, 2, and 3.
yes, I think that's right. Very good. Okay, so let's do that back substitution really quickly. Okay, if z equals 3, then that means this equals 1 here, right? So y equals 2, right? Y equals 2, which means that x plus 2 plus 3 equals 6, which means that x equals 1. So our answer is 1, 2, 3.
Mr. Mike,
Yeah.
every time we change an equation, do we have to keep the change equation, or do we like use it all the way? You know how you multiply like an equation by like -3?
Yep.
Do we use and then we put it back into the additional form, like the change equation?
Generally, it's best to change it back. The reason is because ultimately we need this coefficient in front of here to be 1, right?
Yeah.
And so if we had kept it as -3x, then we would have had to divide in the end anyways. So it's just kind of skipping a step here. Okay, like this -3x here, if we had not divided that now, we would have had to divide that at the end anyways to get it into row echelon form. So that's why I divided it earlier. Yes, yes. Okay, so we have 2 more things to discuss. The first one is what to do when systems have no solution. Okay, so I'll show you guys an example of that. In general, you'll identify a system having no solutions. Quiet, please. You'll identify a system having no solutions when you try to do this process and reduce it to row echelon form, and you encounter some equation like 0 equals 2 or 0 equals 4, something nonsensical, right? So I'll show you an example. X minus 3y plus 3 2x minus y minus 2z equals 2. X plus 2y minus 3z equals -1. Okay, so we'll try this system of equations. All right, what's a good first step for eliminating this?
Multiply the first equation by -2.
Good. Multiply top by -2. All right, if you don't mind, I'm going to write this a little quickly.
Add equations 1 and 2 together. Cancel out 2x on the second equation.
When she comes back. Okay, then I'm going to add the first 2 together. That's going to give me this. Change the first equation back and add the second 2. Add the first and the second together. So 5y minus 4z equals y. Okay. Maybe we'll put that in red. That's my convention. Okay. What should I do to get rid of this thing here? I will multiply the top by -1.
And then add 1 and 3.
Yep. So that's going to give me -x plus 3y minus z equals -1. Okay, then I'm going to add the first and the third together, which will give me Okay, so the negative x plus x is 0. 3y plus 2y is 5y. And then negative z minus 3z is minus 4z. And then negative 1 minus 1 is negative 2. Okay, so already you guys probably see the issue, right?
Yeah.
We have one thing that equals 0, but then suddenly it also equals negative 2. That doesn't make any sense, right?
Wait, so can you just write my solution?
You could, but I'm going to keep going.
Second equation by.
So what, yeah, sure. You could multiply the second equation by negative 1, add it, or you could just subtract them. So I'll just subtract them. Okay, so the second equation stays the same. Quiet, please, Ruhan. I'm going to subtract the second and the third equation from each other. And that's going to give me 0 equals negative 2, or 2. Whatever you did, whichever order of subtraction you did. Okay, and clearly this is impossible, so we write no solution. And this is called an inconsistent system. I'm not quizzing you on any vocab, so feel free to ignore all the words. But when the quiz says, please write this in row echelon form, you do have to know what that means. So
What's that again?
when the quiz asks you to write something in row echelon form, you do have to know what that means.
Okay.
Say it again.
I already said it twice.
It's messed up, Dr. Noah.
It's okay. Okay, any questions? All right, let's do the second case, which is when a system of equations has an infinite number of solutions. So infinite solutions. And we have to know how to express these infinite solutions. I will do one right now.
So in a normal equation.
So basically, whenever you do the row reduction process, and you get something like 0 equals 0, then you know it's going to have infinite solutions. Okay, so that's the hallmark of an infinite solution system.
And you know, it's going to be an infinite solution by
When you get something like 0 equals 0.
0 equals 0.
Okay. All right, so good news. A lot of stuff is already reduced for us, right? This spot is already empty. Next step, we're just going to try to eliminate that. Thankfully, that's very easy, right? You just add the first and the third together. Okay, so we're going to add those together, and we get x plus y minus 3z on the top. Second one stays the same. And then when we add the first and the third, the x and the minus x cancels, and the y plus 2y becomes 3y, and so 3y minus 3z equals negative 1 plus 1, which is 0. Okay. Next, I'm going to divide the last one by 3. And you can see the issue, right? We're going to have x plus y minus 3z equals negative 1. Y minus z equals 0. But then the third equation also becomes y minus z equals 0. So we have two identical equations. And so if I subtracted those two from each other, this is going to be my row echelon form. The final step is going to be 0 equals 0. This would be our row echelon form. And clearly, this is going to tell us that we have an infinite number of solutions. The reason is because we only have really two equations. We only have two equations and 3 variables. So that's not enough information to tell us exactly what x, y, and z are. And so that tells us we have an infinite number of solutions for x, y, and z. But we still have to represent them somehow. And the way we do that is we use what we call a parameter. And we're going to use a parameter called a, just by convention. And so we're going to let z equal a. Okay? A is just going to be some number, any number. And so if z equals a, then that means y equals a as well, right? And if y is a and z is also a, then x plus a minus 3a equals negative 1. Yep. Yep. Which means that x equals 2a minus 1. And so the way that we represent our solution is x comma y comma z is equal to 2a minus 1 comma a comma a. So we use this parameter a in order to represent x, y, and z.
Bro, what?
Okay, so that would be our answer. Our answer is 2a minus 1 comma a for any value of a. And so plugging in any value of a will give us a valid solution for x, y, and z. Right? Say a was equal to 0. Then negative 1 comma 0 would be a solution. Or if a equals 1, then it would be 1 comma 1 comma 1. Or if a equals 49, it will be 97, 49, 49. So all of these are valid solutions. And so that's how we get an infinite number of solutions. But it's not just any solution, right? It has to be in this form for some value of a.
So can we just put no solution instead?
No, that's wrong. Because there are solutions, right? There are an infinite number of solutions.
Infinite solution.
Yeah.
No, because you're not telling me what the solutions are, but just by writing infinite solutions. It needs to be in this particular form. Because those are the specific solutions that are valid, even if it's an infinite number of them.
Infinity.
No, because that's wrong. Because you can't just have any value of x, y, and z, right? If you had 1, comma 2, comma 3, that's not a valid solution because it's not in this form for some value of a.
Okay, so are there actually infinite solutions?
There are infinite solutions, just not all possible solutions.
Could x go to a point where there's no more solutions?
No, x could be any value. But if x is some value, then y and z have to be some specific value that corresponds to that value of x.
Are there